Stuff where I discovered a deep rooted fear in me that I'm afraid of money. I'm afraid to hold on to it as a tool. So I started thinking in terms of what I know and tools and inventions and stuff. I'm just gonna slide down real quick before we slide up. This is a dynamic two-sided scale balance. Like you're gonna put a weight on one side, a weight on other, but it's got a spring support system, so it oscillates a little bit as you're putting stuff on the scale. And what is that good for? Tracing out stock prices based on supply and demand. So it's got supports at 45 degrees. It's got a hinge right in the middle and springs. And there's of course going to be physics involved in it. There's gravitational torque is the input. What we have, gravitational torque, spring torque, mathematical output. It's that oscillatory motion that it's tracing out over time. Yo,
Hi.
what's up?
What? Calm?
Yeah, it's 12:27.
Okay.
Yeah.
My body so bad.
Though there's expected behavior and visual output from it. It's like a polygraph. Over time, it's tracing stuff out. We can determine spring stiffness and damping based off of data. Got a nice little render of that. Now, on one side, you use weights for the supply, the other side, you use weights for the demand. And I originally said, is this output anywhere a model of a stock price? And it said, not really. What you get is market equilibrium. But I said, then what you gonna do? As was trying to do this. But I go back, so I got market equilibrium out of that. And I said, what you're gonna do is you're gonna let the invisible hand put the supply and demand weights on it over time, and it causes the scale to trace out a fluid or oscillatory motion of the stock over time with a little bit of that spring jiggle, not just up and down. So you have a physics of fluid motion where you get some overshoot from momentum, some pullback from correction, and settling from damping. You get to translate that physics to the stock chart. How? If you attached a pin to the tip of your scale's pointer and pulled a continuous roll of graph paper underneath it at a constant speed, the mechanical motion would literally draw a standard financial stock chart. High liquidity, heavy damping; low liquidity, underdamped. There's mathematics behind this master oscillator equation. A brand new differential equation model involving something like acceleration, velocity, plus a constant equals the force of the invisible hand. Inertia, damping, all kind of good stuff. And it traces market waves. And I was actually able to simulate and plot a stock market chart based off of that invention, right? And then that's a single pendulum scale. Due to some of my theories on double pendulums in the stock market, you need a double pendulum scale model in case that's happening. And ended up getting a render of a double pendulum scale model of market chaos. Isn't that kind of cool? You probably could also attach springs to those, but I don't think springs are necessary. So look at some stock data for a company like Google, and determine if it's on a single or double pendulum market. Like, are we in deterministic market equilibrium or are we in market chaos right now? So I'm asking it, pull that stock data for Google and determine if we're single or double. If we look at Google, which is Alphabet, through the lens of our physics models, is currently displaying textbook characteristics of a double pendulum market, where underlying single pendulum fundamentals have been hijacked by a secondary sentiment loop swinging chaotically at the end of the arm. Single pendulum core, the rational scale, the first hinge of your scale, represents the fundamental supply and demand of a company's financial health. That invisible hand just taking it on and off. The second hinge activates the sentiment feedback loop. So Google is a double pendulum market. I'm going to ask, like, deduce the physics of a Google stocks and simulate and plot how far off are we on the time series against the actual stock. Deduce the physics of Google stocks and simulate and plot. How far off are we on the time series against the actual stock? This request takes your concept to its ultimate mathematical destination, using the data from the real world to calibrate and build the mechanical simulator. Here is the deduction of the physics of Google stock and the simulation for 2024 through 26. The fundamental driving, there, it disappeared. It disappeared. We did get a double pendulum market. Oh, don't disappear on me. I feel like a smart person. We'll go back and look at that as it's trying to. There are central restoring springs in there. Some mechanical stock tracer based on supply and demand weights placed by the invisible hand. This was I think the simulation time series convergence check, instantaneous discrepancy. Looks like it's going down. Deducing the physics of the Google market, all kind of stuff. Dynamic market simulation, Axis 1 versus actual chaos, Google actual versus Axis 1 simulation, 24 through 26 fluid harmonic trend, and then May 26 AI talent, Capex shock. So analysis, how far are we off? The single pendulum scale is accurate. Blue chip companies until it isn't. Our deduction's accuracy is high for the macro trend. Our time series prediction error is structurally flawed whenever Axis 2 takes control. Total error over time. Macro convergence, note how much time the error spends near zero or oscillating gently. This proves that our single pendulum scale deduction is fundamentally accurate. It correctly identified Google's fundamental value trajectory. The chaos divergence at T approximately 14, which corresponds to June 26, the chaos hinge activated. Our model red kept gliding, but actual Google blue plunged. Quantitative error, we're off by nearly $100 per share instantly. This is not because the fundamental model was wrong, it's because the fundamental model ceased to be the dominant physical force. Wow.
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 Number 2.
Oh, okay. Yeah.
Okay.
Yeah.